Here we're a company using both NX and Solid Edge to design our machines. Or it could even be that one of our suppliers is using Solid Edge to design certain aspects for us. We'll start in NX, and of course since we're working in the context of Teamcenter, we're using Active Workspace to search for and open the top level design. The aim here is to show how we can seamlessly use Solid Edge to design and construct one of the control panel assemblies that sits on the right hand side of this machine. So we'll switch to Solid Edge and start by opening the master layout assembly, again via our Active Workspace integration. Once the assembly is open, we'll use the Create Part in Place command to define a new subassembly in the context of the design. This creates the relevant items and item revisions in Teamcenter. Then we can start constructing our sheet metal enclosure. As we do this, we can easily reference geometry from any of the NX parts to ensure the panel fits correctly first time. Once the initial tab is created, a couple more sketch elements allow us to use a contour flange to define the enclosure. Here the corners are automatically mitered where necessary. Next up, we need to create the mounting holes that attach the panel to the frame. Once again, showing the background parts allows us to make sure we're working in the context of the assembly by referencing the existing NX geometry. This ensures they are in the correct position and right first time. Once the sketch geometry for the holes is created, they can be pushed through the model. Another hole on the bottom of the panel will allow for the connection of the harness cable later on. Then we need additional holes on the front of the panel for the screen and control buttons, followed by the assembly of these components from the Teamcenter library. And our new panel is complete. Back in NX, we need to assemble the panel. So we'll use the Add Component command and pick the new design directly from the Teamcenter library and pop it into place in the overall design. Then we'll save our assembly and finally turn on the display of the harness cable. Back to Solid Edge now. We have a design change that needs to incorporate the contents of the left panel into our newly designed right panel. To help here, we're going to use the power of synchronous technology, starting by copying the mounting hole locations from the left panel to the Windows clipboard. Then we can switch back to our new panel and make the desired changes. We'll do this as a revision to the existing design and use Teamcenter to first revise the assembly and then the sheet metal box itself. We can then stretch the width of the panel to make it 250 mm wider. Then move the mounting hole for the harness. And then we can paste the mounting locations that we copied previously. Synchronous makes this whole task a breeze as we use the steering wheel to help get the position of the holes correct with reference to the rest of the model. A final attach creates the holes. Then we can assemble all the new components into place by dragging from the Teamcenter library. We'll now make one final edit to reduce the overall height of the panel slightly. Again, synchronous technology is our friend here to make the task quick and simple. And our modifications are complete. Back in NX, we'll integrate the new design revision back into the top level assembly. Here we can see the existing design is derived from the JT data that Solid Edge created, and that revision B is available. We also have a 2D drawing of the GA, which is now out of date. We'll close our existing subassembly, then reapply our revision rule to force it to use the latest revision, and then show the revision B assembly and all of its components to see the new design. Then we'll force an update on the control cabinet so that the harness cable updates correctly to the new location. The final step is to update the views in the 2D drawing. So there you have it, the interoperability of Solid Edge and NX working in perfect harmony in the context of Teamcenter.